All right, so welcome to P6. This is the last of our sort of preliminary sections, and the last section before our first test. More info on that to come later. This is about rational expressions. So an expression, not quite an equation, but has some variables in it. But so not an equation, so no equal sign yet. We'll be dealing with equations in chapter 1, which will be coming up soon. Rational really just means fraction. So a rational number is a fraction number, any number that can be written as a fraction. So pretty much what this is, a rational expression, it's just a fraction made of, for us, polynomials. So a fraction of polynomials. And so what we're going to do is essentially just go through what would be all of our typical fraction rules. So that is any kind of restrictions, right? So fractions have restrictions where you can't divide by 0. And then, right, fractions you can sort of simplify and reduce to lowest terms. There's going to be a version of that. You can multiply and divide fractions. So we can multiply and divide rational expressions. And we can add and subtract fractions with common denominators. So we'll do the same thing here for rational expressions. So everything we do here is essentially a sort of polynomial fraction version of what would be a normal sort of fraction operation. So let's start at the very beginning. I've heard it's a very good place to start. So for instance, so what are these going to look like? So you could have something like 2x over x minus 4. You could have 3x squared minus 9 over x plus 2. You could have just like negative 5 over like x squared minus 4. All this stuff counts for us as a rational expression, right? So it's just polynomial stuff. We'll keep these relatively short. We're not going to do really big, long polynomials here, if only because that would just be a lot of work, I guess. Take more time. It's not really what we're after, is making the most complicated version of things here. We just kind of want the most standard version of things. So first things first, whenever you have a fraction, right? So for fractions, you are not allowed to divide by 0. I guess just sort of in general, we're not allowed to divide by 0. So what that means for us is no zeros in our denominator, right? We need to make sure that we don't have any zeros in our denominator. At which point you probably would say, well, it doesn't look like we will, right? We're going to have x minus 4s and x plus 2s and whatever. And I would say, yeah. So that stuff doesn't look like 0, but in theory, any of these x's, we need to sort of think ahead, right? If we were going to evaluate these expressions and start to put some numbers into them. And so we need to kind of think ahead and think about what are the kind of numbers that would make the denominators 0. And we need to essentially make sure we avoid them. We're gonna exclude them from what we call our domain, which is, I think we'll define here in a second. So no zeros in the denominator means we need to exclude any values for x that make our denominator, equal to 0. We need to just exclude them. We're going to sort of like find them in advance, and then essentially we're just going to say, oh, by the way, don't use those numbers. It's really not going to be anything more fancy than that. They're just like, we're sort of putting them on the do not call list. We're putting them on the do not use list. So the wording for this, the different x's that you can sort of input into an expression, is called the domain. So the domain are all possible x values that can be evaluated in your particular expression. this idea of a domain will sort of come back over and over again. So I just want to sort of have this here on the table. It also is the language the book uses in the homework. What we're doing is we're excluding values from the domain. So meaning we're excluding x values, finding x values that would give us a 0 in the denominator and therefore just sort of break our expression. So this isn't really anything super fancy. Let's just sort of take just our first one we had there. So 2x over x minus 4, right? So all we're going to do is just take a minute, find all the x values to exclude from our domain. So literally all I'm going to do is just like take the denominator, and I can kind of do this, I can kind of write this, one of two ways. I guess in theory, right, what we're doing is we're trying to say x minus 4 cannot equal 0. So I'm just literally going to write x minus 4 not equal to 0. This is essentially the equation we're trying to solve. Now you might say, what do you mean equation? This is literally a not equation, right? Because it's not equals. And I would say that's pretty clever. That's nice wordplay. Nevertheless, we'll think of this as an equation. X minus 4 is not equal to 0. And so we can do all of our same, add, subtract, multiply, divide, all of our typical, what would be our typical sort of equation moves to solve an equation, we can do here. I literally just said we're not really going to do equations yet. We're going to do them in the next section. That's still true. We're just doing a couple simple things here. So if what I have here is x minus 4 is not equal to 0, how am I going to figure out what the x is not equal to? This is the part where you're probably yelling at your screen. Just add 4 already. The answer is 4. And I'll say, okay, right? So if you add the 4 to both sides, this would get us essentially a quote-unquote kind of solved version of this exclusion equation, right? X is not equal to 4. So if x minus 4 can't be 0, that means by itself x cannot equal 4. And that's going to be our restriction. It's the only one we've got, right? I don't really need to worry about anything in the numerator here. In theory, you might say something, well, 2 times x at top, right? Do I need to like exclude x equal to 0 because 2 times x would be 0? And the answer is no. Everything up top is totally fine and is in play. Right? The top here just is its own thing, is a numerator. And we don't need to worry about whether or not we're going to get a 0 on top or not. We can just sort of take whatever number we've got and we can work with it. Let me put another couple up here. So same instructions. Let's do negative 4 over like x minus 6, right? Find all the x values to exclude from our domain. So this one again is really short. All I'm doing is I'm just taking the denominator. X minus 6 cannot equal 0. If I do just a quick, right, add the 6 to both sides, this means for us x is not allowed to be 6. And we're there. It doesn't really matter that in this case we don't even have an x up top. That's totally fine. Whether or not we have an x in the numerator doesn't even really matter. This is still a rational expression because it's still a fraction made of polynomials, aka, for us, sort of a fraction with variables involved, with x's involved. What would one look like that was a little bit more complicated? How could we sort of take this up a level? What if we have a bigger polynomial on the bottom? Maybe something that we'd even need to factor. So same thing, right? Find all my x values to exclude from the domain. So again, I'm not even really looking at the top at all. All I'm looking at here is this x squared minus 4. Now, this is an interesting one, right? So we have a polynomial x squared minus 4. So this is not just a matter of necessarily just sort of adding, subtracting values. You could kind of get there if you like added the 4 to both sides. That would mean x squared equals 4, and you could kind of reason out, well, that would mean the x could be 2 or negative 2 in theory. What I'm going to suggest instead is do a factoring problem, right? Just like from P5 when we were factoring. This is our nice difference of squares. X squared minus 4. So that would factor as x minus 2 times x plus 2. And so in theory, kind of what we're doing here is kind of a preview of one of our next sections from chapter 1 where we solve quadratic equations. I don't love this. The book essentially has us solving quadratic equations before we've really talked about what it means to solve a quadratic equation, but here we are. So the idea is that if you factor this, right, into 2 chunks, what you get are 2 shorter equations, kind of like what we had up here, right? This was sort of just x minus 6 equals 0, and we could just add the 6 to both sides. The concept here, if I break this into 2, these guys are multiplied together, right? So the idea is this whole thing, you know, sort of this sort of smaller, right, this kind of factor times this other factor, is not going to be equal to 0 unless one of them by themselves is 0. If they're both positive, if they're both negative, if one of them is positive and one of them is negative, you're just going to get either a positive or a negative number. You're not going to be able to multiply 2 non-zeros and get a 0 out of it. So the only way for this to hit 0 would be to either have x minus 2 hit 0 or have x plus 2 hit 0. Or in this case, because, you know, our sort of non-equations, these unequations, have x minus 2 not be 0, have x plus 2 not be 0. We're doing like triple negatives or something now. The whole idea with both of these cases, right, is individually, these will get us 2 pretty quick restrictions. So x minus 2 cannot be 0. If you add the 2 to both sides, that means that the x can't be 2. These are pretty obvious once you break them down in a way that maybe the original one here is not so obvious, right? X squared minus 4, maybe at first glance you don't realize, but once you break it down, x minus 2, you would have to exclude positive 2, and then on the other side, if we subtract 2 from both sides, that means x cannot equal negative 2, right? That's kind of the basics of it. If we had maybe one more just kind of quickly, where we had to factor again. X squared minus 4 is one where you have that sort of nice difference of squares, so maybe the factoring there, maybe you kind